Okay. So I guess the best way to start out is introduce yourself.
So I'm Luke. I'm a software developer specializing in database work, and especially a specific kind of analyzing patterns and then developing a database architecture that allows you to routinize things. It's probably too complicated to explain right now, but suffice it to say that it got me looking for patterns and how to characterize patterns with some sort of schema.
Okay.
Which is, programmers love to do that sort of thing.
Right.
So, but I did that for a while, and then I did some quadcopter work well before consumer grade drones were popular. And that was interesting to try and build professional grade equipment with consumer grade parts. It ended up not working so well. I mean, yeah, so that's its own long story. And then moved to San Francisco and decided that I didn't want to just be a code monkey. And so I started giving myself a liberal arts education, reading people like Charles Taylor and Alistair McIntyre, and broadening out from there, going kind of crazy. And I like to say that the internet is my university. I post regularly on a theologian's blog, but I also on some atheist blogs, and try and communicate the things I'm learning in these books that scholars will regularly read and argue, but talk about them with people who are everyday people who like to argue. So not just everyday people, but these people like to argue, comments going back and forth and back and forth and back and forth ad nauseum. And it's like, if I can understand this stuff well enough to explain it to them, then maybe I actually understand something about it. And also, I have a heart for taking the hard work done in academia. I mean, some of it's crap, but some of it's good, and making it accessible to your average blog goer. Because otherwise, they so easily get caught in ruts, whether it's young earth creationism or whatever. You get caught in ruts. And it's like a lot of the scholars have figured out some of the ruts, and then you could use what they've discovered as cheat codes to take the conversation in new directions. And so I've done a lot of that in the last 7 years, and being mentored by a sociologist, and I'm looking to try and provide better software and engineering support for scientists these days, sort of planning on a 2-year program to do that. Okay.
So you're still working as a programmer?
These days, I'm taking a hiatus from earning money and thinking about starting a company. My father passed recently, and so the inheritance options allow me to not have to convince people to pay me to do this for 2 years.
Right.
And I'm kind of pissed off at the free market. Scientists suffer in a lot of ways doing their science, and the free market doesn't see them as a group that'll pay very much to help them. And so the really expert software and engineering talent gets put to Northrop Grumman or Google or whatever. Right. When scientists could really use some pretty basic stuff. It's almost boring, but imagine that you didn't have standard 115 volt power. So much would not be possible. And yet, in a sense, it's boring to maintain 115 volt power. So that's kind of where I'm headed for the next 2 years.
Yeah, we'll have to when we shut this off and go backstage, I want to talk to you a little bit about programming and science.
Sure.
I want to show you something. Anyway, so what I'm a programmer. So what languages and database were you doing that?
So I was doing C# and SQL Server for the job, but I've done C++, I've done a little bit of Lisp, done a little bit of Haskell, done Verilog, which is actually a hardware description language when I was working at JPL. And I actually started on Visual Basic, which is supposed to screw you up for life, but I don't think it did.
Yes.
Python. So I've been around.
Visual Basic is still a thing?
So I believe it was VB6 or earlier that I actually started out writing a calculator program where I said, if textbox1.text equals 1 plus 1, set textbox.text equals 1 plus 1 equals 2. I got all the way up to 6 plus 6, and then my cousin showed me variables, and I didn't like them in the beginning. This isn't like
well, yeah, Visual Basic, God, I was doing that 35 years ago, I think, or something like that.
I don't know when VB1 came out, but yeah, that might be about right.
Yeah, in fact, I did an entire signal processing language, and I used, I did it in C, but I used Visual Basic as a basically paradigm for how to do it for radio engineers to do signal processing. and to do testing on signal processors. So basically, I created a compiler for this
Cool.
company called E.F. Johnson. I think they made CB radios or something like that. I don't know.
Okay.
Yeah. Anyway, yeah, nerd stuff. I could get into it forever, but okay. Anyway, you're a Christian, but not a young Earth creationist.
Correct. I used to be a young Earth creationist.
Really? Okay.
Whenever someone online says that nobody is argued out of any position via online discussion, I was argued out of young Earth creationism to intelligent design and then to evolution entirely by online discussion.
You're going to have to tell us how that happened so we could reproduce it and bottle it, because that's kind of our goal, is to stomp out young Earth creationism, basically.
Yeah, well, it started with the off-topic forum, apolyton.net, which is the Civilization forums. I don't know if you ever played Civilization 2, or Sid Meier's Alpha Centauri, or any of those games. They're the turn-based strategy games. So you're the dictator of a nation, and you have to discover scientific technology and build out infrastructure and wage war and all that stuff. And so this is when, let's see, in the beginning, I probably had a 38.8 baud modem that I was dialing up to access the forums. I don't know that I had to start on a 9600, but
I had a 110. 110 baud.
I believe it. I believe it. So it was off-topic forums, and I loved it. And I brought a lot of the stereotypical young Earth creationism arguments, because that's what I was raised with. But I guess they sensed that I was honest, and they're actually remarkably polite. I wouldn't be surprised if things have soured a little bit over the years as the arguments have dragged on and on. Talk Origins was around, but they were a little condescending in my experience. This is a sort of vague recollection. But it was really the people who just kept going at it with me, and it could take like 5-6 times hitting the same issue before you break through. It's just convincing people takes forever. You have to be really patient. Otherwise, give up on ever convincing someone on anything interesting. And the argument that really won me over, though, I mean, a whole bunch of things had been weakened at this point, but the argument that won me over was young Earth creationism is not helping us ask new, interesting questions in science. It's not showing us new, interesting places to look for fossils. It's not showing us anything interesting. It's just saying you can't do this, you can't do that, you can't do that, you can't do that. And so, and what they said is, even if evolution were proved wrong right now, even if I were somehow convinced it was wrong, I wouldn't care. I would keep using it because there's nothing better out there. Show me a better. Right.
It's like a full stop mentality. It's like, how do we get from prokaryotes to eukaryotes? Well, magic. It was just created. And then as soon as you say that, then you would stop looking for ways. And the problem with believing in evolution, like to tell you the truth, the more I learn about evolution, the more somewhere there's this little guy in my head that's saying, who in the hell would ever believe this shit? Right?
Yeah.
Because what you have to do is you have to imagine, you have to know enough to be able to imagine the mechanism to get from point A to point B, in organismal types. And that takes a lot of work. But I think the average person would rely on the consensus, that the consensus of textbooks and biologists and, whatever are evolutionists. We call them evolutionists.
That's how the Brits pronounce it. Evolution.
Evil. Yeah, evolution.
Anyway, the first time I heard Dawkins say that, I just cracked up.
Yeah. But but that's kind of what I'm trying to do is take that detailed understanding of how you get from point A to point B and turn it into this story of evolution and try to make it palatable for people, because everybody, I guess, it depends on how much you want to work at, believing in what you believe in. Like, for instance, as far as some fields like physics, I'd made the decision that I'm too damn old and I only have one life to give, so I cannot get into physics, right? Yep. So I'm going to have to accept what the mass of people say about physics and believe that. Okay. I have no choice. I can't go double check it myself. I don't have time, so
Yep.
some people can approach it that way. But so okay, so
Actually, can I pause you on the mechanism thing? So there's a book on the extended evolutionary synthesis, which is taking us beyond the modern synthesis.
Smith
And
and
one of
Markowitz
the sorry,
or Smith and who's that by?
Pigliucci is one of the I think it's an anthology. I have it, I believe.
I got one.
Um, hmm.
I think it's the extended synthesis by, let's see. Synthesis. I think Smith is one of the authors, and I can't remember who the other one
Yeah.
was.
I'll have to find it for you later. But the thing that he claimed is that for a long time, you were just supposed to accept that somehow evolution works, but the mechanisms weren't really spelled out in very much detail.
Right.
And just saying that there's random mutation and natural selection is not enough to actually do it. You need to do all sorts of really fancy stuff, like niche construction is one of the things that's being discussed now. And before all these details,
is that it?
Yes, I believe that's it. Yeah. Okay. And so what Pigliucci writes in that is that they were just beginning to really articulate the mechanisms in any interesting detail. And so before that, you really did have to fill it in with your imagination. Yeah. And you know that engineers tend to be more likely to be young Earth creationists and intelligent design advocates than...
Notice that. Engineers and also biochemists are a little more likely
so think about
biologists.
I have some sort of a hypothesis, is that engineers can't just insert, well, somehow it works here, because when they build a product, they have to cover all their bases, and it has to be a robust result, and it has to operate without them somehow making it work in the background.
Yeah.
And that is such a different mindset than a scientist. A scientist has to, first of all, your experiments are held together by spit and duct tape. And also, your first attempts to understanding a thing, you can't build anything like a bridge with that. It's some ideas that you throw against the wall and you see what sticks.
Right.
And an engineer is never allowed to work that way. They get laughed at by their fellow engineers if they ever try and do that. And so it's a really big cultural difference that I think is beginning to get recognized. I haven't really kept up on the evolutionary stuff, so some of my knowledge might be dated here. The evolutionary versus creationism stuff. But I think you nailed it with, you have to imagine the mechanisms. And evolution is still pretty young in the scheme of things. Like, you can do nothing like a computer simulation from abiogenesis all the way to intelligent life that can run a simulation, right?
And so even if you could do a simulation, you would not know all the details that happened. I mean, you could develop an algorithm that could do it, but then you would have to record every state of that algorithm as it went through like a million cycles in order to totally understand what it was doing, right?
Yeah, I'm more thinking that if you can get something that generates intelligent life that goes on to make a simulation, right?
Yeah.
So that's the criteria. It doesn't have to look human. Star Trek is all humanoids, but it doesn't have to look human. It just has to have that property of this interesting self-reflection on your history and trying to simulate it. If we were able to pull that off with, biochemistry and probably biochemistry is that would have to be true in the simulation, and you could actually make it work, then that would be really cool. One fun thing would be if you try doing it with other planets being visible versus not, because planets show an extreme regularity that can help you think about things in a very, very baby steps. Like a lot of Islamic science was understanding time in order to do their rituals at the right time, but they developed some pretty sophisticated stuff as a result. Now, what happens if they had no planets to time keep, right? If they only had the rising and the setting of the sun, maybe they couldn't. And so you could play with all these variables and then simulate it and see if you can possibly get intelligent life at the end. We're just so far from that. We're ridiculously far from that. And so the scientist has to use his or her imagination to fill in the gaps.
Yeah, complexity is, the space is so astronomically huge, biological complexity, even in one cell, that it is impossible for us to get our minds around it. So you have to do the imagination. So you can't think about it in, machine-like manner.
Alan Kay, who's a bit of a legend in computer science, he invented Smalltalk or co-invented it. He gave a talk, I believe, in 2000 called "The Computer Revolution Hasn't Even Started Yet," and he mentions the complexity of the cell and the need for radically new ways to think about computation in order to possibly tackle that. And one of the themes of the talk was that we keep forgetting the things we've discovered in computation and theory of computation, maybe more computation. And I don't know what the current state of the art is on simulating that stuff, because yeah, it's super ultra complex, but it's like, hopefully you can somehow simplify and still capture some of the patterns so that it's empirically adequate to some extent. I just don't know where we are with that. I do know that the EU dumped €1 billion into this thing called the Human Brain Project, and they were trying to do a sort of neurons up simulation of the human brain, and it failed pretty catastrophically. They sort of played it as a success, but we're really far from being able to do that kind of details.
That's where they simulated one cortical column. I think it was a subcortical column of a rat or something. That project. Yeah. Well, it was good, but yeah, they did play it as more of a success than it was. It's kind of huge. This is kind of an aside, but Haskell, how far did you get with Haskell? Haskell's a bitch, isn't it?
Well, it's mind bending. The furthest I got was normalizing a database schema with Haskell.
Okay.
And it was actually really cool because you could describe the semantic steps you were taking with very few lines of code, and so you don't get lost in all the implementation details. The obnoxious thing in that class is that I wrote this wonderful code to do it, and then I forgot exactly all the details. And then on the final exam, you couldn't use code you'd written, and they didn't tell me, and so I got a few points off on my third normal form or whatever it was.
Have you heard of Bartosz Milewski? I put a link in private chat for you.
Been getting a little bit into category theory here and there. It's a very interesting topic, especially with some of these things we're talking about now. But I'm not sure I've run across that guy. I've run across David Spivak, who's a researcher at MIT.
Yep. Bartosz is the most amazing person to watch. And I've gone through his category theory a couple times. I always get lost with products in some manner because there's something about my mind that needs to be stretched into a different shape in order to get my mind around category theory. But anyway, I put it in the side chat, but we probably shouldn't talk about that. But anyway,
let's hit up we might be coming to category theory from very different directions. I'd love to follow up on that some later time because I'm banging my head at it as well.
Yeah. Okay, cool. And he does it with Haskell. So it's his thing, and he's just wonderful to listen to. He's pleasant. He's got this accent. He's just a great guy. Anyway, so you're a theistic evolutionist. You believe that God created the universe in such a way that we happened.
So what I would say is that right now, I don't know of any way that positing agency helps us understand more about evolution than having no agency. And so even theistic evolutionists, it doesn't help us do anything more than we already can. And so that's not where my theism goes up in my life. I mean, you might call me a theistic evolutionist, but I'm just not sure what it adds to believes in evolution.
Yeah. Well, the way I understand it, there are various shades of it. And you remember I think I mentioned bridge a couple times in our study group. The bridge between atheism or naturalism and theism, that sort of thing, that if you go all the way back around, there's this bridge. And the bridge kind of happens at I guess both a theistic evolutionist, a real hard, I would call it a hard theistic evolutionist, would believe that God, banged the universe or, did the expansion and just let it go, fully knowing that it was going to create life, that because of the periodic table and the structure of carbon and the way carbon combines, it would just happen, that sort of thing. So that would be the same as a naturalist saying there was a big bang and everything naturally created. So there would be no fight there, no fight
Yeah.
between us. And that is sort of a bridge, and an interesting bridge, because then when you start thinking, we'll get a little bit into what we believe, but when you start thinking about man's ability to comprehend what that God would do is about just as weak as man's ability to comprehend what a natural universe does in all the complexity, right? So the two things are almost equivalent, and there's a bridge there, where we can all get along.
There is a difference, and that is if you try and build your ontology or metaphysics off of what, say, physicists and chemists do, maybe even biochemists, agency never really shows up. And that's, of course, the whole thing with intelligent design or creationism, is that agency was needed. And the counter argument is, no, it's not needed. Show us where your ideas of agency can help. And so that's the one thing where, when we do science other than, say, some of the social sciences, we kind of forget that we know anything about agency. That's kind of the point, is you're supposed to prescind from any knowledge of agency and then just think in terms of mechanism or mathematics.
Yeah.
And so what does agency add is a big question that we can get into whenever you want.
Yeah. And then when you understand, like I worked on neuroscience for quite a while, and my understanding of the mind is that mathematics is the agency. That basically it creates this complex that becomes agency.
That's kind of Platonic.
Yeah, maybe, but not entirely. I think Platonic might have a few elements that I don't quite agree with, but anyway, we are agents. We are we are the best agents I know of. Human beings, or have the most agency function, right? We can sit around and plan shit and go out and build tables and things like that. And but all of that comes up from that naturalistic complexity. And when you look at how the mind is structured, you can see how it does that, basically, how we do agency, that sort of thing. And there we'll find a point of disagreement between us, right? Eventually.
Well, I mean, there's actually, I happen to be privy to a more than $5 million grant given to some interdisciplinary teams of philosophers of science and such to understand what agency and purpose are. Yeah. And so those are actually very ill understood concepts right now.
Yeah.
Because I'd actually point to a book by Robert Rosen. He's a theoretical mathematical biologist, called Life Itself. And his contention is, if you try and define what life is only using, say, differential equations, say using Galileo's ontology of these idealized particles or tiny little billiard balls, you can't actually say what makes life different from non-life. And it's a very interesting argument that he makes very rigorously. Yeah. And I think that goes interesting places in terms of what you can explain naturalistically, because naturalistically, either you have to cinch down exactly what that term means, and then it might actually be wrong because there might be more complexity to the world than that term, or you make it vague enough that it can encompass anything, but then it's not a good explanation by any sense of like what Popper would understand as the best explanations. The best explanations rule out everything but what actually happens in some sense. And so if you can explain things that don't happen, that's a little problematic, especially if it's so vague that you could explain all sorts of things. And my favorite example for this is Newton's equations of motion and the orbit of Mercury. Yeah. So Mercury's orbit mismatches the best, like when you take in so many different factors, far more than Newton knew about. Orbit of Mercury, the precession of the perihelion of it is off by 0.007% a year. Now, most people, if they could get that kind of theoretical to practical, observational match, they're going to be really, 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 really happy. Yeah. But that's a problem for Newtonian mechanics, and it turns out general relativity solved that one for us. But most explanations, like I haven't come across any explanations anywhere near agency or even evolution that is so precise that you could even detect a 0.007% difference between theory and observation. Yep. And so the more vague things are, the less helpful you are in explaining how reality works.
I don't know. I've got a book back there somewhere. I think it's called something about behavior. I forget who it is. God, what is the name of it? It's by some philosopher. He starts talking about behavior, and he breaks it down pretty well. Let me grab it.
Yeah.
Explaining behavior.
Okay.
By Dretzky, Fred Dretzky.
Okay.
I don't know, it might be a little dated, but anyway, and I haven't read through it to find out if he decides that we can explain it, but I think we can. I think pretty well mechanistically. I don't think intention or agency are that difficult to imagine for the organism that we are and with the brains that we have.
It's a very interesting claim, given the failure of AI to do any interesting agency stuff.
Well, AI is a little the failure of AI has to do with our approach to it, right? Okay, in order for an AI to work like we want it to work, like we do, right? Like our brains work, you got to put it in a body like ours. You got to give it senses like ours. Mm-hmm. And then you have to give it an upbringing like ours, right? And where have we done that? Where have we actually tried to create a AI child, with all the senses that a human has or that some animal would have, and then give it an upbringing so that it can acquire the world in steps from, the moment it's born up until it's about, 15 years old. If you raise it that way, AI will be possible and will be a lot easier than we think.
So I do find that argument compelling in terms of a very important way to actually pull it off. Marvin Minsky, I forget the name of the book, but he talked about having an
Society of the Mind.
Oh, that might be it. He talked about playing with blocks. That's about as far as I got in the book.
I was talking about it yesterday on our weather report.
Oh, okay.
About blocks, how you build a bridge with blocks, that sort of thing. Yeah, that was Society of the Mind.
Yeah,
or it might have been The Emotion Machine. I think he wrote 2 books.
Yeah, I haven't read any other Minsky. But the thing that stuck out at me, for some reason, I was thinking about the arbitrary rule systems that humans make that don't have smooth contours too. If you get things a little bit wrong, it can be catastrophic.
Yeah.
Whereas playing with blocks, there's a lot more, what I want to say, smooth manifolds in terms of success and failure. So you can succeed and then you make it a little worse, and then it fails, but you can explore. And when you have even roughly smooth or not crazy chaotic, think about it as fitness landscapes is probably a good way to think about it. If they're sufficiently smooth, you can use fairly simple algorithms to explore them. Yep. And what kids do when they're young, I think, is they do a lot of that exploration where the fitness landscape or, I want to grab onto something, you can get partial success, more success, more success. And so there are a lot of iterative options and so forth. And so I completely agree that something like what you say is very important. But here's the question. Does nobody who has the money and resources to do this believe that this is a good idea, or has it actually been tried and has it failed?
I don't think it's actually been tried. And if we did, it would, we're a ways technologically from pulling that off to the degree we have to pull it off. Here's Minsky's 2 books. Well, he did 3 books, Computation, Finite and Infinite Machines. I would like to get that one. That was 1967. The Emotion Machine was another one that he did, which you might like. So if you like Minsky, it's there. And interestingly enough, I think I spotted a picture of a fitness landscape back here, or something like it. Oh, no, it's a profile of a coin. Okay. Anyway.
It looks like it was Finite and Infinite Machines that I might have gone off of, actually. I don't know which one.
Yeah. Anyway, Society of the Mind is one you're talking about, the blocks.
Oh, okay.
He talks about acquiring this basic knowledge of how the 3D world works and materials work and things like that. Okay. It's very interesting. And anyway, my views on consciousness is that consciousness is not in your brain. It's in your brain, body, and the world around you within a locality, right? That all those things together form this, these consecutive blurry little brushstroke slices of time that are our experience. And if you didn't have the world around you, you would pretty much be like a computer. You'd be pretty dead. If you didn't have all this input coming in, working with the brain over, over your lifetime, consciousness wouldn't be a thing. You'd be unconscious. That in order to be conscious, you have to have this constant influx of stuff happening, that sort of thing, which is kind of cool. And that goes to my strange Buddhist view of being connected to the world, and being, and just passing through the world as this kind of like buzzy little sparky being, right? That's really highly connected to its surroundings. And then one day I'll die, and then I'll stop being sparky, be more like a rock, that sort of thing. But anyway, if we want to pull off AI, we are going to have to figure out, first of all, we have to figure out, do we want to do that? What do we really want to do? What kind of intelligence do we want? Do we want a totally different kind of intelligence? How intelligent do we want it to be? And all that shit. I mean, and then we got a lot of work to do to figure out what the parameters are. It'd be interesting to create a universe where the metaphysics was different, where objects didn't go behind each other or something like that, or maybe a 4-dimensional world, and bring up an AI in this 4-dimensional world, or 4D plus time, so 5-dimensional, and just find out what the hell the thing thought,
If you trace the history of philosophy, I kind of wonder whether that's some of the stages that AI might go through in reflecting on things. Because it starts out really simple, like Parmenides and Heraclitus. They're really simple. Their world is pretty simple in comparison to our booming, buzzing confusion.
Right.
I mean, it's simplified as well as, I think it was simpler. I mean, we have how many versions of lawyer? Back then, I don't think you had very many different kinds of lawyer. And so we have a really complex world in comparison, but I think their philosophy was even far simpler than their social world. Yeah. Yeah.
Okay. So you think there's something else to agency besides neurons?
Yeah. So the thing that's big with agency is self-reflection. You can think about things, and that aboutness is, as far as I understand, it's still a fairly mysterious relation. I'm not like trying to put God in there or anything. It's just we're kind of stuck with aboutness, especially self-reflexive aboutness. We get stuck on things like the liar paradox, like the sentence is, and since we don't seem to have really good ways to do sophisticated talking about the system, we are going to lack a lot of understanding of how to develop agency, because agency is super meta. It goes meta arbitrarily many levels. And yet, do we have any software development practices that go meta arbitrarily many levels? Generally not. Even very basic provers that says this function definitely does this thing. The math to show that it does that thing is almost as complicated or as complicated as the function, which means that you're as prone to make errors in the prover as in the function. And there seems to be a property of this ability to go meta where you get simpler as you go meta in some ways. And you can verify that the more complex version that you're talking about stays within the parameters that you've described. And that's a very abstract description. So what would be a good example? This is where I need to really develop a repertoire of good examples of that.
As do we all.
Here's an example. It's a little on the simpler side. So I use Evernote on my iPad, and Evernote is getting slower and slower. And I think it's because I take tons of notes on books. I copy out big sections from PDFs and then take comments on them and highlight them. And it's getting slower and slower. And they're also adding features. And what I want is a description of what the software is doing and timestamps on how long it's taking to do it, so that I can look over time. I can look at those logs and say, it's getting slower and slower to do this because this operation is growing with linearly, or maybe even quadratically with the size of the corpus it's searching. And another nice example actually of this would be that there's a New Yorker article called "Why Doctors Hate Their Computers." And the problem is that doctors used to spend lots of time talking to their patients, and then they'd scribble on charts and stuff, and then all get processed. But we want to move to electronic health records, and we want the data to go immediately into the computer. And so let's develop some software for it.
Right.
But they do these ridiculous things like, if the patient says this, then you have to fill in this field. And doctors are not trained to do computer stuff quickly. And so they end up looking at this computer screen. You're the patient there, and I'm asking you questions, but I'm facing the computer screen. It's taking longer, and it's a worse interaction.
Yeah, I've noticed that lately.
Yeah, and so I'm being mentored by a sociologist. I'm a part of a group that's a philosophy of biology and sociology reading group. I actually meet Wednesday mornings, and it's because of how the stakeholders are consulted or not consulted. And it's because of just how you understand developing software. But it's more than that. The software doesn't know what purpose the doctor is trying to accomplish at any stage in the software. There's no like description layer. I'm trying to accomplish this purpose.
Okay.
And imagine that the software is guessing at the purpose you're trying to accomplish. It's figuring out how frustrated you are. And if you're saying, no, I'm trying to accomplish a different purpose, then the software would be like, okay, or it'd be like, you should probably be using that screen instead. But this description layer of purpose on top of the mechanism and the interface being shown, we're not used to thinking that way in any sort of rigorous way. Yeah. And if we can't do that kind of thing rigorously, trying to understand what agency is, I think because agency is built on top of being able to accomplish various different purposes. It's also embodied, so you have all that problem. I just believe that we're going to need tremendously better mathematics and maybe new metaphysics, ontology, causation thinking, especially how you protect the going meta process, as well as negotiating with other people. And when the way I think about reality is different from you, and yet we can still get along, then there's some sort of reconciliation between your way of thinking about things and the way I think about things, where there's not too much slippage and, we get annoyed and pissed off at each other, but then we reconcile. How do you model all that stuff so that computers could do that with each other? Right. That's really complicated.
Yeah. Agreed. So. I've got a weather report in about 17 minutes, and I got to get off in about 10. Yep. But I think I want to continue. But I guess my question is, why in the hell are you a Christian?
So I was preparing with your two topics, and it sprung on me. The reason I adopted evolution is because people said there's nothing better. You show me something better. Even if I'm convinced it's false, I'm going to keep going with it until you show me something better. Okay. That's why I stay a Christian, is that I've not seen anything better out there. And in particular, a lot of people like to focus on chemistry and physics as like the things that you should think of all of reality in terms of these. And the reason is probably we've had so much ridiculous success from Galileo till now. It's just amazing how much success we've had. But we're actually running out of gas with them, in my opinion. And there's some technical details like Einstein's God does not play dice was actually, he didn't want to admit that there could be non-local properties, non-local reality, non-local things in reality at the deepest level of existence. He wanted everything to be either billiard balls, point particles, or fields where if you specified the value of the field at every single point, you say everything about the field. But we're finding out with entanglement and some other things, depending on your interpretation of quantum mechanics, that non-locality might actually exist. And that violates the idea that everything is made up of point particles. It's like a deep clash of ontology.
Well, it violates more so it violates the idea of a Cartesian 4D space-time.
Yep.
Could be be a very, very different geometry involved.
Yeah, and when you look at Bohmian mechanics and the entity that they have that, say, the Copenhagen doesn't have, it's super complex and weird, and it's like, how is reality like that? And so it really violates our everyday intuitions of what things are like. So anyway, going back to your question, though, I haven't found anything better that helps me understand what I call human and social nature and construction. So think of the characterizing what humans do, how they do it, why they do it, all and in groups, and sort of how does the individual work with the group, and all that stuff. I've found nothing better that looks like, I don't know if you, in Physics 101, you learn about a point particle that's charged above an infinite plane of sheet charge, and you can calculate the force and do stuff.
Right.
It's highly idealized, and yet it's a building block for doing physics and understanding. And I compare a lot of the Bible as providing those kinds of idealizations for understanding humans and how humans operate and groups. And this isn't to say it's not historical, but it's definitely, you don't get a lot of details. If you try and make a movie of anything in the Old Testament or New Testament, you have to add a lot of details in order to actually film it and have it be there, right? But I found no other source that tries to teach how humans operate that is anywhere as accurate as the Bible is.
Okay.
And just one more thing. It operates a bit weirdly, though. It operates like a skeleton key, where only when you find a lock do you actually see that part of the key in more detail. So it's like a concrete situation. Oh, if you take this concrete situation, you look at this bit of scripture, then it starts to bring it into more focus. And it's like a way to characterize things a lot more than if you just look at them and try and figure it out on your own. Okay.
So a metaphorical interpretation of the Bible.
It's not. I wouldn't call a point charge hovering above an infinite sheet plane metaphorical, because that's not quite what it is. Like, physics isn't taught by metaphor. It's just, it doesn't seem like quite the right word.
Yeah.
It's more a simplification. And a simplification that excludes irrelevant details so that you focus on the right things in the beginning and you aren't distracted by irrelevancy.
Okay.
And true things can be told that way. They can be told simplified. I mean, all of history is simplified. You can't say every position of every particle at every time, right? You have to select things out. And yeah, so
I always freeze when my phone rings. It freezes my camera.
Oh,
I don't know why. My Mac doesn't, so I'm not sure why. But
you could disable receiving of phone calls through your Mac if you wanted, or maybe do not disturb it during video.
Yeah. Okay, so we have a hell of a lot more to talk about. So we're gonna have to schedule another. We're gonna have to schedule another session, because I think there is a way. Well. Okay, there's the reductive science is something that has irritated me all of my life. Okay, rather than reductive, just molecules, just chemistry, whatever. Imagine sodium and chlorine and whatever. I call it constructive. So I have a constructive naturalism, which is kind of opposed to that, and expands out in another way. But I think that in principle, if you had enough time, if you had a universe covered with paper, you could write out the formulas you needed to do to explain anything, basically. Okay, that's my intuitive grasp of it, that we could do it. We may not have the right geometry right now, the right physics, hence we don't have the right metaphysics, but in principle. But as far as humans are concerned, and as far as biology is concerned, I think the problem is a lot simpler than the physics problem. So, and I think we can explain agency, morality, and whatever. But do we want to reduce it to that? No, we don't. Okay, so if you have something metaphorical like the Bible that has this skeleton key ability to understand things in very different ways, that is valuable, unless you believe in the ontology of it, I guess, is where my atheism comes from.
So I would push back in this way. We assume that reality is that our universe is a closed system. And there are very specific reasons for doing so. The mathematics is far easier, and all our work on thermodynamics and statistical mechanics has assumed equilibrium conditions, because you can use stuff like the Boltzmann distribution to make the math tractable. And
Yeah.
physics has a habit of ignoring problems where it can't find the math tractable. It's changing now with non-equilibrium thermodynamics. Like Jeremy England has some interesting stuff going. But we have a hammer, a really sophisticated hammer that works in closed systems. And
Yep.
everything looks like a nail. And so what would it look like for the world to be an open system? And then you get into things like miracles. And there's like two really different categories of miracles. One category wows us and causes us to despair of our own resources, our own understanding, and follow some authority. Another category of miracles, I claim, could empower us to become more capable and more generous and more understanding and more willing to suffer the obnoxiousness of others. And it's a very different kind of miracle, but most Christians, in my experience, really like the miracles that wow you, like Elijah on Mount Carmel. So the setting there was Elijah, one guy representing Jehovah, and then 450 priests of Baal. And they're going to see who can light the sacrifice on fire with a lightning bolt. And so Elijah wins it. But the effect on the people is, for like 10 nanoseconds, ooh, yes, Jehovah only is God. And then Queen Jezebel says, okay, putting a price on Elijah's head, let it be done to him what he did to my priests of Baal. And so Elijah flees. That's all the miracle accomplishes. This magic, this wonderful display doesn't have any long-term positive effect.
Okay.
But so much thinking about miracles from both Christians and atheists thinks that if you saw a real live miracle like that, you would be bowing and paying attention. It's like, that's actually a worship of pure power. And it's an inversion. Like, we value science because it shows us the orderliness of the world, and then we can discover even more and build awesome things. If you love miracles that are human law breaking, like massively law breaking, not like precession of Mercury, tiny bit law breaking, but massively law breaking, then you devalue everything that humans have figured out about how reality works. Yeah. And so if the world is an open system where God can build into us, but he wants to do it in a way that enhances us and helps us understand the process, it's going to be a really subtle interaction. And here we could go back and talk about what theistic evolution might look like.
Okay.
But yeah,
cool.
I've not really seen God interacting with the world described this way. As far as I know, it's kind of unique to me. It's come from arguing with atheists for probably over 30,000 hours at this point. Okay. But I think it's the best way to understand scripture, because Jesus is a servant of people, and he tells his followers to be servants and servants of the people who work with the grit of reality, the bottom people. And if you empower them, right? And I'll end with this. Rome, in ancient Rome, probably 90% of the people were farmers. Imagine if you go to them and you say, I'm going to empower your farmers to be far more efficient, make their lives better, and they'll accomplish 10 times as much. Only 10% of your population, or 9% of your population, has to farm. What would the ancient Romans say to that? And they're two general answers. You want to give what do you think they would say to that proposal?
Well, it sounds like they would be all for it, but...
Well, it depends. The farmers were slaves and peasants who were of no use to anyone other than doing manual labor.
So there's that. No purpose. No purpose.
The one little problem of this actually came from my mentor. He's like, but they could field much larger armies if they had that. So, but the pissy attitude toward the people on the bottom that they had is Rome was extremely hierarchical. The pissy attitude they had toward the people on the bottom meant that they didn't help them do their jobs better and have a nicer life, which meant that they didn't have all the wonderful things that you and I have, because America probably employs less than 5% of its population to farm. And that means we can do so many more interesting things in the world. And so what would happen if we did that again and again and again? What happens if we make scientists 10 times as productive by serving them? But this is a way of building into the world that's not miraculous in a fire from heaven sense, right? Right.
Subtle. Yeah. Okay. That would be a good place to start, is miracles, and probably next time I want to talk about a little bit about Buddhism.
Yeah, I'd love it. I don't know very much about Buddhism. So.
Okay. Yeah. I think I have some people think a very strange view of it, but anyway, but I'm all for it.
I like
Okay.
strange people.
Yep. So we'll end there, and we'll call this just part 1, and we'll do part 2.
Sounds good.
Okay.
This was awesome. Thanks.
Okay, I'm gonna end the recording. So.